what I want to do in this video is go over the math behind a mortgage loan. And this isn't really going to be a finance video. It's actually a lot more mathematical, but it addresses, at least in my mind, one of the most basic questions that's at least been circling in my head for a long time. And we take out these loans to buy houses. Let's say you take out a $200,000 loan, mortgage loan. It's secured by your house. You're going to pay it over 30 years. Or you could say that's 360 months, because you normally pay the payments every month. The interest normally compounds on a monthly basis. And let's say you're paying 6% interest. This is annual interest, and they're usually compounding on a monthly basis. So 6% divided by 12, you're talking about 0.5% per month. Per month. Now, normally when you get a loan like this, your mortgage broker or your banker will look into some type of chart or type in the numbers into some type of computer program, and they'll say, oh, okay, your payment is going to be $1,200 per month. And if you pay that $1,200 per month over 360 months, at the end of those 360 months, you will have paid off the $200,000 plus any interest that might have accrued. But this number, it's not that easy to come along, because let's just show an example of how the actual mortgage works. So on day 0, you have a $200,000 loan. You have a I'll just write $200,000 loan. You don't pay any mortgage payments. You're going to pay your first mortgage payment a month from today. So this amount is going to be compounded by the 0.5%. Maybe I should write 0.5%. And as a decimal, that's 0.005. So in a month with interest, this will have grown to 200,000 times 1 plus 0.005. So 1.005. Then you're going to pay the $1,200. So it's going to be minus 1,200. Or maybe I should write 1.2k. But I'm just really just showing you the idea. And then for the next month, whatever is left over is going to be compounded again by the 0.5%. 0.005. And then the next month, you're going to come back and you're going to pay this $1,200 again. Minus $1,200. And this is going to happen 360 times. So you're going to keep doing this. And you can imagine if you're actually trying to solve for this number, and at the end of it, you're going to have this huge expression. It's going to have 360 parentheses over here. And at the end, it's all going to be equal to 0. Because after you've paid your final payment, you're done paying off the house. But in general, how did they figure out this payment? Let's call that P. Is there any mathematical way to figure it out? And to do that, let's get a little bit more abstract. Let's say that L is equal to the loan amount. The loan amount. Let's say that I is equal to the monthly interest. Monthly interest. Let's say N is equal to the number of months. Number of months that we're dealing with. And then we're going to set P. We're going to set P is equal to your monthly payment, your monthly mortgage payment, some of which is interest, some of which is principal. But it's the same amount you're going to pay every month to pay down that loan plus interest. So this is your monthly payment. So this same expression I just wrote up there, if I wrote it in abstract terms, you start off with a loan amount L. After 1 month, it compounds as 1 plus I. So you multiply it times 1 plus I. I in this situation was 0.005. Then you pay a monthly payment of P, so minus P. So that's at the end of 1 month. Now you have some amount still left over of your loan. That will now compound over the next month. Then you're going to pay another payment P. And then this process is going to repeat 300 or n times, because I'm staying abstract. So you have, this is going to repeat. You're going to have, I guess the best way I can express that is that you're going to have n parentheses. And after you've done this n times, that is all going to be equal to 0. So my question, the one that I'm essentially setting up in this video is, how do we solve for p? If we know the loan amount, if we know the monthly interest rate, if we know the number of months, how do you solve for p? It doesn't look like this is really an easy algebraic equation to solve. So let's see if we can make a little headway. Let's start with, let's see if we can rearrange this in a general way. So let's start with an example of n being equal to 1. If n is equal to 1, then our situation looks like this. You take out your loan, you compound it for 1 month, 1 plus I, and then you pay your monthly payment. Now, this was a mortgage that gets paid off in 1 month. So after that one payment, you are now done with your loan. You have nothing left over. Now, if we solve for p, and I'll swap the sides, you get p is equal to L times 1 plus I. Or if you divide both sides by 1 plus I, you get p over 1 plus I is equal to L. And you might say, hey, you already solved for p. Why are you doing this? And I'm doing this because I want to show you a pattern that'll emerge. Let's see what happens when n is equal to 2. N is equal to 2. Well, then you start with your loan amount. It compounds for 1 month. You make your payment. Then there's some amount left over. That will compound for 1 month. Then you make your second payment. Now, this mortgage only needs 2 payments. So now you are done. You have no loan left over. You've paid all the principal and interest. Now let's solve for p. So I'm going to color the p's. I'm going to make this p pink. So let's add p to both sides and swap sides. So this green p will be equal to all of this business over here is equal to L times 1 plus I minus that pink p. They're the same p. I just want to show you what's happening algebraically. Minus that pink p times 1 plus I. Now, if you divide both sides by 1 plus I, you get p over 1 plus I is equal to L times 1 plus I minus that pink p. Now, let's add that pink p to both sides of this equation. You get the pink p plus this p plus p over 1 plus I is equal to L times 1 plus I. Now, divide both sides by 1 plus I. You get the pink p over 1 plus I plus the green p. They're the same p. The green p times, it already is being divided by 1 plus I. You're going to divide it by again by 1 plus I. So it's going to be divided by 1 plus I squared is equal to the loan. Something interesting is emerging. The loan, you might want to watch the videos on present value. In this situation, you take your payment, you discount it by your monthly interest rate, you get the loan amount. Here, you take each of your payments, you discount it, you divide it by the essentially 1 plus your monthly interest rate to the power of the number of months, and so you're essentially taking the present value of your payments, and once again, you get your loan amount. And you're going to see, you might want to verify this for yourself if you want a little bit of algebra practice. If you do this with n is equal to 3, I'm not going to do it just for the sake of time. If you do n is equal to 3, you're going to get that the loan is equal to p over 1 plus I plus p over 1 plus I squared plus p over 1 plus I to the third. Now, if you have some time, I encourage you to prove this for yourself, just using the exact same process that we did here. You're going to see it's going to get a little bit hairy and there's going to be a lot of manipulating things, but it won't take you too long. But in general, hopefully, I've shown to you that we can write the loan amount as the present value of all of the payments. So we could say, in general, the loan amount, if we now generalize it to n instead of an n equals a number, we could say that it's equal to, and I'll actually take the p out of the equation, so it's equal to p times 1 over 1 plus I plus 1 over 1 plus I squared plus, and you just keep doing this n times, plus 1 over 1 plus I to the n. Now, you might recognize this. This right here is a geometric series. This right here is a geometric series. And there's ways to figure out the sums of geometric series for arbitrary ends. This is a geometric series. As I promised at the beginning of the video, this would be an application of a geometric series. It's equal to the sum of 1 over 1 plus I to the, well, I'll use some other letter here, to the j from j is equal to 1. This is to the 1 power. You could view this as to the first power. To j is equal to n. That's exactly what that sum is. So let's see if there's any simple way to solve for that sum. You don't want to do this 360 times. You could. You'll get a number. And then you could divide L by that number, and you would have solved for P. But there's got to be a simpler way to do that. So let's see if we can simplify this. So let's, just to make the math easier, let me make a definition. Let's say that r is equal to 1 over 1 plus I. And let me call this whole sum right here, let me call that s. This sum right here is equal to s. Then if we say r is equal to each of these terms, then s is going to be equal to, this is going to be r to the first power. I'll write r to the first. This is going to be r squared, because if you square the numerator, you just get 1 again. So this is plus r squared plus r to the third plus all the way, this is r to the n. Plus r to the n. And now I'll show you a little trick. I always forget the formula, so this is a good way to figure out the sum of a geometric series. Actually, this could be used to find the sum of an infinite geometric series if you like. But we're dealing with a finite one. Let's multiply s times r. So r times s is going to be equal to what? If you multiply each of these terms by r, you multiply r to the first times r, you get r squared. You multiply r squared times r, you get r to the third. And then you keep doing that all the way. You multiply r. Let's see, there's an r to the n minus 1 here. You multiply that times r, you get r to the n. And then you multiply r to the n times r, you get plus r to the n plus 1. All this is right here is all of these terms multiplied by r. And I just put them under the same exponent. Now what you can do is you can subtract this green line from this purple line. So if we were to say s minus rs, what do we get? I'm just subtracting this line from that line. Well, you get r1 minus 0. So you get r1, or r to the first power, minus nothing there. But then you have r squared minus r squared cancel out. R third minus r third cancel out. They all cancel out, all the way up to r to the n minus r to the n cancel out. But then you're left with this last term here. And this is why it's a neat trick. So you're left with minus r to the n plus 1. Now factor out an s. You get s times 1 minus r. All I did is I factored out the s is equal to r to the first power minus r to the n plus 1. And now if you divide both sides by 1 minus r, you get your sum. Your sum is equal to r. I don't have to write r to the first. You just write r minus r to the n plus 1 over 1 minus r. That's what our sum is equal to, where we defined our r in this way. So now we can rewrite this whole crazy formula. We can say that our loan amount is equal to our monthly payment times this thing. I'll write it in green. Times r minus r to the n plus 1. All of that over 1 minus r. Now, if we're trying to solve for p, you multiply both sides by the inverse of this, and you would get p is equal to your loan amount times the inverse of that. I'll do it in pink because it's the inverse. 1 minus r over r minus r to the n plus 1, where r is this thing right there. And we are done. This is how you can actually solve for your actual mortgage payment. Let's actually apply it. So let's say that your loan, is equal to $200,000. Let's say that your interest rate is equal to 6% annually, which is 0.5% monthly, which is the same thing as 0 0.005. This is monthly interest rate. And let's say it's a 30-year loan. So n is going to be equal to 360 months. Let's figure out what we get. So the first thing we want to do is we want to figure out what our r value is. So let's figure out our r value. So r is 1 over 1 plus I. So let's take, so it's 1 divided by 1 plus I. So plus 0.005. That's what our monthly interest is, 0.5%. And close parentheses, and that is equal to, so 0.995. That's what our r is equal to. Let me write that down, 0.995. Now, this calculator doesn't store variables, so I'll just write that down here. So r is equal to let me write a 0 in front of it. 0.995. We just used that right there. I'm losing a little bit of precision, but I think it'll be OK. The main thing is I want to give you the idea here. So what is our payment amount? Let's multiply our loan amount. That's $200,000. 200,000. Well, let me just write the whole thing. 1, 2, 3. So that is 200,000 times we have 1 minus r. So 1 minus 0.995. 1 minus 0.995 divided by r, which is 0.995 minus 0.995 to the, now n is 360 months, so it's going to be 360 plus 1 to the 361 power. So something I could definitely not do in my head. And then I close the parentheses. And my final answer is roughly $1,200. If actually you do it with the full precision, you get a little bit lower than that. But this is going to be roughly $1,200. So just like that, we were able to figure out our actual mortgage payment. So P is equal to $1,200. So that was some reasonably fancy math to figure out something that most people deal with every day. But now you know the actual math behind it. You don't have to play with some table or spreadsheet to kind of experimentally get the number.